Here we are in this video, we are going to do the chemical properties of acids and bases, class 10. Well, there are 4 of them. Let's start with the very first of them. That's a reaction of metals with acids and bases. So how acids and bases reacts with metals. So the general reaction is that most of the acids react with most of the metals. That means those metals which are above hydrogen in the activity series to give salt and hydrogen gas. Here's one such example you can take. Let's say HCl is an acid, reacts with a metal zinc to give a salt called zinc chloride, and hydrogen gas is produced. You may take more examples, like say, for example, if I take say some other, let's say magnesium, right? We can take other example. For example, if I take another metal, say if I take magnesium here, magnesium, and take an acid, say H2SO4, sulfuric acid, it will give a salt called magnesium sulfate, MgSO4, and then hydrogen gas is released. So one thing you can clearly see that irrespective, whatever is the metal and the acid here, if the reaction takes place, then hydrogen gas is produced. So this is how a metal reacts with an acid. Now, what about the base? If you see the reaction, it says the base also the reacts with metals to give salt and hydrogen gas. Let's say how they are different. Important thing to remember here that most of the acid, as I said, most of the acids reacts with most of the metals, that is metals above hydrogen in the activity series to give salt and water. But that's not true in bases. Not all bases reacts with all metals to give salt and hydrogen gas. There's few specific bases reacts with most of these active metals, like active metals could be sodium, zinc, etc., to give salt and hydrogen gas. So the product remains the same. Here also the product so formed is hydrogen gas. As I told you that there are only few specific examples you can take, therefore it is necessary to remember this reaction, right? So one such example, you should learn it, as you won't find many of them. So therefore, remember this. And this is sodium hydroxide, which is a strong base. When it reacts with a metal like a zinc, it gives sodium zincate and plus hydrogen gas. This is important to remember the name of the salt here, that is sodium zincate. Its formula is also very important to remember. I repeat that you won't get many questions, its name, and you won't get many such examples. So it becomes important to remember one specific, and you should know this. There could be some others, but as given in your textbook, that sodium hydroxide reacts with zinc to give sodium aluminate and hydrogen gas. Moreover, you know that hydrogen gas, we can test the presence of this gas by bringing it near a burning splinter. This gas burns with a pop sound. One such question based on this is what happens when sodium hydroxide reacts with aluminum metal? So let's take aluminum metal, that is Al, when it reacts with sodium hydroxide, that is NaOH. So the result here, as you can see, this is a metal and it's an active metal again, and reacts with sodium hydroxide is a strong base. So the product here so formed is, that is sodium aluminate, that is NaAlO2, and plus hydrogen gas is released, right? Its name is sodium aluminate. And as you know, this base reacts with metal to form hydrogen gas. So the correct option should be this one, that is sodium aluminate and hydrogen gas is formed. One more question based on the same concepts. That says a metal reacts with dilute acid to produce hydrogen gas. Just we did. Which of the following metal does not react with the dilute acid, right? We have to choose a metal which do not react with the dilute acid to produce hydrogen gas, or the reaction will not take place. So as I told you, those metals which are above the hydrogen in the activity series should give you hydrogen gas. That means this will give you hydrogen gas. This reaction will take place. This too is an active metal. Copper is also an active metal, but aluminum. But copper, as you must have seen, that it is below hydrogen in the activity series, right? So copper is below hydrogen in the activity series, and that's the reason this will not react with hydrogen. This will not react with dilute acid to produce hydrogen gas. The next is the reaction of the metals with metal carbonates or metal bicarbonates. Bicarbonate is also called metal hydrogen carbonate, right? Metal bicarbonate is same as metal hydrogen carbonate. So first we should know that there is no as such reaction that takes place. Base, right? Base plus metal carbonate or metal hydrocarbonates, right? The reaction does not proceed. So we have to remember the reaction of metal with or metal carbonate, sorry, metal carbonate with acid. So acid reacts with metal carbonate or metal hydrogen carbonate to give three products. And what are these three products? One is salt, carbon dioxide, and water. These three things are produced whenever a metal carbonate or a metal bicarbonate reacts with an acid. So you can see one example where hydrochloric acid reacts with a metal carbonate. Here we have taken sodium carbonate to produce salt, sodium chloride, carbon dioxide, and water. As you can see, irrespective whether it's a metal carbonate or a metal carbonate, as in case of the other part, you are getting the same product here, that is salt, water, and carbon dioxide. Now, the carbon dioxide so released, as you know, it can be tested by passing it through the freshly prepared lime water. It turns lime water milky. Now, why does the lime water turns milky? That you should know that whenever this carbon dioxide, this gas is passed through lime water, this is calcium hydroxide. Aqueous solution of calcium hydroxide is called lime water. It forms a precipitate which is an undissolved substance produced during the reaction. This precipitate here gives the milky color to the lime water, and that's why the lime water turns milky. But you will observe that if excess carbon dioxide is passed through this, I repeat, if you continue to pass more and more carbon dioxide to the same reactants, what happens? This calcium carbonate so produced during the reaction now starts reacting with the excess or the extra carbon dioxide, right? And that results in the formations of a calcium bicarbonate. But remember, this calcium bicarbonate is not an precipitate as it's an aqueous solution. So therefore, the milky color disappears. I repeat this. Metal carbonates reacts with metal carbonates or metal bicarbonates reacts with an acid to form salt, carbon dioxide, and water. And we know how to test the presence of carbon dioxide. When carbon dioxide is passed through the freshly prepared lime water, the lime water turns milky, and the reason is this calcium carbonate. This is a precipitate. But when you pass excess carbon dioxide into the solutions, it results calcium carbonates now turn into calcium hydrogen carbonate, or this is calcium hydrogen carbonate, and this is an aqueous solution. This calcium hydrogen carbonate is an aqueous solution, and therefore the milky color disappears. We have taken I've taken three questions based on this concepts. The first one says that name the gas evolved when hydrochloric acid, dilute hydrochloric acid reacts with sodium hydrogen carbonate, and how to recognize this reaction or the gas so produced. As we just did that metal carbonate, like sodium hydrogen carbonate is a metal bicarbonate. So this is NaHCO3. When it reacts with an acid, it's an HCl given here. So what happens? Three products will be formed. One is salt. The salt has to be NaCl and carbon dioxide and water. These are the three products so formed. So how can we recognize this gas so produced? The number one, this gas is a colorless. As you know, carbon dioxide is a colorless and odorless gas. So if we cannot smell it or detect it through its color, so we have two tests here. Number one, we can pass it to the freshly prepared lime water. If the lime water turns milky, it shows the presence of carbon dioxide. The second is that it extinguishes a burning candle. The next is what does an acid give when it reacts with metal carbonate, as we just did, it forms three products. One is salt, second is carbon dioxide, and third is water. So carbon dioxide, water, and this salt. So therefore, the correct answer should be all of these. Right? All of these is the correct answer. Now, let's move to the next question. Last question, it says a metal A reacts with dilute hydrochloric acid to produce an effervescence. So we may write the reaction like this. Say the metal A is a metal carbonate, right? Could be any metal carbonate. So let me write down, say Na, say CO3. As of now, we don't know what will be its actual formula. It says it reacts with an acid, so it's HCl. And when we see what is produced here, an effervescence, so the gas is released here. So the gas evolved. When you read the later part of it, it says the gas evolved extinguishes a burning candle. That means the product, one of the product is carbon dioxide. So what do we know that here the acid reacts with metal carbonates to produce salt, waters, and carbon dioxide. Now it also says one of the products so formed is calcium chloride. That's the one of the products so formed is calcium chloride here. That is CaCl2, calcium chloride. Now from here we get to know that the metal carbonate has to be of calcium, and the metal carbonate made up of calcium, right? The A will be replaced with calcium carbonate. That is here A is calcium, right? Here is A, this is A is calcium. Why? Because the salt so produced is a salt of calcium, right? Calcium chloride. And as you know that the third product here is water. The general reaction, once again recall it, metal carbonate reacts with acid to produce salt, carbon dioxide, and water. Now further the question says that you have to write the balanced chemical reactions. I have done the reaction, you can balance it. And they're also talking about in the later part is to write down the test for this gas. The gas so released is carbon dioxide. So we can write any of them. It burns it extinguishes the burning splinter, or better you should write down, when this gas is passed through freshly prepared lime water, it turns the lime water milky.